My name is Mike Benshoof. I'm a technical account manager with Percona, and prior to that was on the consulting team with Percona. And this is my colleague, Alexander. He's a principal architect with Percona as well. And we're going to walk through some of the features that you can use for some geospatial analysis in MySQL, both in 5.7 and 8.0, some of the new features that have come out that actually were talked about a little bit in the keynote. And so it's meant to be kind of an introduction to the topic and not necessarily as much of a deep dive, but just give you an idea of some of the features and how you can use it in your applications. So what we're going to talk about is just kind of what is geospatial in general and how it can be used in your applications and what it might be used for. And then we're going to talk about how it is used in MySQL and then also in MongoDB. So a little bit of a comparison between the two and sort of the evolution of geospatial as it's gone through different versions of MySQL. So in general, kind of what is Geo Data? I'm assuming people here are aware of what it is, but it encompasses a wide variety of topics. Really anything that talks about your location, where you are, mapping, point data locations, and also kind of boundary areas. And generally there is some sort of function of distance. And so, very common questions that we ask when we look at geospatial data: how many restaurants are nearby me? How long is it to the airport? How many miles am I from this closest point of interest? And those types of common questions. With the geo-enabled devices, these types of questions are very common. Last night going to dinner, what's the nearest restaurant to me? You say that into your phone, it knows where you are, and it can calculate distances to various locations. When we talk about other industries, oil and gas exploration, meteorology, logistics companies, pretty much any industry, there's going to be a need for geodata and geospatial analysis. So really kind of the overall point, if you're not already using it, which you may be and you don't even realize it, you should be soon, because it is a very important thing to be using. So when we talk about kind of the high level of what we're looking at distances between points on a sphere. So this goes through the Haversine formula. I'm not going to walk through that, but it's there for your reading pleasure. Definitely not something that people are calculating in their head very quickly. So what we've tried to do is go through the various iterations of MySQL and see how we're able to calculate those distances. So when we look at prior to 5.6, you're going to be writing your own functions for that. You're going to be writing helper functions. And you're going to be doing a lot of work, but you can get pretty close. Once we had 5.6, we introduced the StDistance function. So some of those custom user-defined store procedures, they're not needed anymore. So you can use the StDistance, but there were some limitations around that. Once we got to 5.7, we added additional spatial functions, and we also added spatial indexes to MongoDB, which really made spatial usable starting in 5.7, because generally, one of the things we talk about, if you are concerned about your data, you're probably not storing it in MyISAM. So if you're trying to use MyISAM just for the purpose of using geodata, there's some concerns there. And then once we go into 8.0, which was kind of discussed in one of the keynotes this morning, the world is not flat anymore. So what we're saying is that it's no longer just the Cartesian plane. We're able to actually use SRIDs that are helpful in calculating distances around the globe. So let's look at kind of some examples, and we'll work our way through some of the older versions to where we are now. So here's a sample going through and just saying, okay, I'm going to set my latitude and longitude. I'm going to give 1 degree of separation between 2 latitude lines, put in a very lovely formula and query that everyone would love to write, and see, okay, we got roughly 69 miles between latitude lines, which is what they should be. But again, that varies depending on where you are in the globe. So that's why this is more of an estimation. So when we take that type of structure, prior to 5.6, we would build our traditional zip code table. This is something that I'm sure people have seen before, where it's a list of all the zip codes or points of interest, and you have a latitude and a longitude decimal field. And then you're going to store that in there, and you have your index on lat and lon. So we talked about the fact that you needed to write your own function. So when we try to come back with, let me get my distance in miles, there's no particular function that would exist for that. So you're writing your own function, you're going through, and again, you're using that estimation formula that we use. So it's not 100% accurate, but it at least gives you an idea of how far things are apart. So we put that together, and we can give ourselves a source starting point, and we can run through and say, give me all the areas that are closest to me sorted by their distance. And that gives us a result set, and if you look at that, I only got 10 rows and it took me half a second. So that is not really a great time. Let's look at the explain here. So we can see by looking at that, I'm doing a full table scan, I'm reading through all of my results, and then I'm sorting it at the end. So really not an ideal explain plan. So what we tried to do in earlier versions was we took that concept and we set a box around what we're going to try to do called a bounding box. And we would say, okay, I'm going to be close enough, so let's limit our result set that we're scanning and not scan the full table, and let's come up with a min and a max latitude and longitude range and try to squeeze down our result set that we're looking at. So now you can see it's basically the same query, but we've added the extra where we have the betweens where we've done those calculations. So my application did the calculations. It said, here's my starting point. Let's go a few miles to either side. Let's shrink down our space. And now we can go ahead and we can get a much more respectable time. It's still not perfect or great, but at least it gives us an index instead of a full table scan. So we go through all this and basically say now we're able to start using spatial data types. So this is where we can start to have something interesting that we're able to use. So we already talked about the non-spatial way. So we've got our individual decimal columns, and it works, but you have to do some extra things to make it performant. When we start talking about the geospatial way, we're now using a geometry type, and we can do points or polygons. And so this is where we're looking at, as opposed to just an actual numeric value, we can actually start creating our own bounding boxes and our geometries and our shapes. And then once we got to 5.7, we were able to add the actual index on that to make it usable. So that's one of those things we talk about. Just because the feature's there, you need to be able to index it so that you can go through it quickly. So where does this take us with our actual table structure? So as you can see before, we had our lat and our lon as individual decimals. And then now as we move over, we're going ahead and we're going to create a geometry column to replace those two. And so now within that geometry column, we can use the actual point feature. So looking at that query, so now instead of doing an actual column select and pulling the individual pieces, we're getting the actual geometry object that's stored now as a spatial object. So that's really exciting, but we just had a query that already did that. So really, what is any better, what's better about this? Because not only did we already have a query that did that was even easier to read and more standard SQL, it was the same amount of handler operations. It used the index, we're still scanning the same amount of data. So the real reason that this is exciting is that now we're using our GIS-based calculations on other objects and not just points anymore. This opens up a lot more possibilities. So everything prior to this was based on the single latitude and longitude, right? So it was just individual points. And there were a lot of freely available databases that you could download that were based on this model. Or you could crawl through the postal service, whatever you wanted to do to get the information, it was readily available. Well, since the geospatial and the shape regions have increased, we now have the actual census provided database that has these. This is an example. It's a little bit older one. There is the more recent one as well. They generally come out with one of these every year, and that gives you those zip code databases that you used to pull with individual points. And it gives you regions now. So here is what that table looks like when you actually pull that directly out of the tool, and that's mainly using a conversion to pull it from a shape file and load it directly into MySQL. And if you look here, now instead of our lat and lon, we have the shape field, which is the geometry type. And because we're in at least 5.7, we can do a spatial key on that type. So that is where we get the actual performance and we get a usable solution. So when we looked before, we had an original point for our zip code. So you can see the type was a point. So even though it was stored as geometry, it was just a point. So we were very limited to our location with it. Now, in this newer version, we have a polygon. So it actually goes around the city limits and puts all of our points around it. And it's just a shape that is based on the actual location. So as opposed to just a, where is this exact point and find me a point that is close, I actually have a region that I can look in. So some of the functions that come through that we can use are StContains, StWithin, and basically there's a whole list of these ST functions that are going to be your spatial functions. StContains is going to look to see, here's I'm giving you a point, and I'm also giving you a region. Give me a yes or no, is this point within that region? So that's very powerful, and you can use these things also in joins. So we'll look at some of the queries later with how that can be leveraged in a join. StWithin is a very similar function, and again, you can go through all of these functions through the manual, and there's a laundry list of them. So now let's look at how we can use some of these queries with the geospatial and the region-based as opposed to just single points. So we've got our zip code table, and we also have a points table. So that would be something that a restaurant, you're going to have an actual lat and lon position for it, or you're going to have points of interest or things like that. What we're going to try to do from that standpoint is now, as you can see, we're joining that table and we're doing a join on that StWithin. So now, as opposed to say, find me everything that is within this distance and sort by distance, I can actually join on that geospatial function to find every single point that falls within a certain zip code. The next example is going to be a very similar thing. You can see we're using the StContains instead. So what that is now I'm taking my primary table and I'm saying, show me all the points of interest within this polygon. So across that join, I'm able to say, here's my region, find me all the points within that using that spatial index that's on there. And again, now you can keep building up and have more complicated queries that come from there. This is very similar to the earlier query, but I'm now joining other tables that have additional information. So now I have multiple zip codes. So I want to come up and I want to say, okay, find me everything within this county. So now I can go ahead and find all the zip codes, join back against my zip code table, and then leverage my StContains to say find all the points in multiple pieces. And it's done in one query, and it's actually indexed now in comparison to prior versions. So, we talked about it earlier, and we said, all right, we had spatial functions, but what real big, game changer happened with 5.7? We now have indexes. Let's just take a look at one of these queries and see the impact of adding that, because, a lot of times, sometimes people will say, well, might not necessarily need an index for this, or I can get around it, I can work through it. But let's take a look at the difference in performance. So here's with and without the key. So you can see the difference, and this is, again, just running on a VM locally. It's nothing special with hardware, but the same query going through, and we took 1 minute to go through and scan everything versus, sub 100th of a second response time. And you can see the handler operations have changed from my 33,000 handler operations to scan the table multiple times down to just the 4. So we can see right here that if I was trying to actually run this query in production, I'm not going to have anything usable. No one's going to sit there and wait a minute for that to find me points that are nearby. So that really does show the overall impact of that spatial key. So MySQL 8, as you heard probably in some of the keynote discussions this morning, we added some new functionality and some really big things that make this even more usable. In 5.7, as we talked about, we added the spatial indexes, which helped. So now we've updated some of those ST functions that we talked about, and they actually are used to calculate distances on the globe. So as opposed to just looking at the flat Cartesian plane, and this was where I talked about in the slide earlier that things are round now, it's not just the flat geometry anymore, this has been added. So the other piece that, and I think that I saw this one as one of the bullet points in the keynote as well, the ST is text. It will actually do a translation and return your lat and lon based on the spatial reference system that you're in. So it's no longer reversed order and other things that happened in earlier versions. And really the big one that was added here is that prior to, we had these spatial functions, but we were always using an SRID of 0, which was essentially just the Cartesian plane. Now we can actually use geographical coordinates that are meaningful, and as we move around the globe, the ST distance will actually handle where you are in the globe as opposed to just a straight geometry difference. There are still other functions that need helper functions, but as as more releases will come out in 8.0, they're going through and adding this ellipsoid distance support in other functions. So you want to definitely check in the manual as you're going through it as they're adding it. So you still need helper functions for some of these, but kind of ST distance is a big one, so that's the one that they started with. So just to kind of show again, and this, to show you in sort of the real time, I've got just a quick demo to show how we can actually make this usable. And so this is in no means meant to be a complete walkthrough of either my Python code or anything else, but it's just something to show you how you can actually use raw data, load it into MySQL, and calculate something interesting from it. So what this demo is going to do is it's going to, basically I let my phone run with a mapping program that I use, and did a drive to my in-laws' house, a couple 100 miles, just let it run, captured all the points, and what I want to do is come back and say, how far did I actually drive in each county? Probably not all that exciting, but it's something. So, all right. So I've got my GPX file. It's just a raw file, nothing that is, again, out of the ordinary. And we're going to go ahead and we are going to find out how far I did. So what this is doing is it's taking the raw file, it's loading it into the database, and then it's taking all those individual points, mapping it back against the that census database that we talked about, and then calculating the distance between all those points once I have what locale I'm in, and then keeping a running total. So again, not the most elegant thing, but you can see that reacted pretty quickly for a 200-mile drive to actually map it out and get geographic information about that. So to kind of show the impact of what that key was, I mean, we looked earlier and we saw that, yeah, it was definitely, with a small sample set, it was noticeable and it was 1 second or not. So I'm going to run this again, and I have the exact same program using the exact same data, but I have, in my zip code table, I took away that spatial key. So that's really the only difference that's there. So we can see this is called no index. The file is literally a copy and paste of each other, and it's just a table that has no index. So I am going to start that, and then we'll go back to our slides. So to look under the hood at what this was doing, we can see this is the actual main piece that takes my raw points. So I think there was, 5,300 points that were captured over that 200-mile drive. And what it's doing is it's basically using that join on the within. So what's interesting here is when it looks, it says that it's doing the all, but this range checked for each record is basically saying that once I have my points, then I'm able to leverage that index and actually find it. So while it's coming across as an all, it is using that shape key, and as it's looping through each record, it is leveraging that index. So we can see that, with 5,000 points, you would think with a 40,000 row table that I'm doing my scans on, I would have a much larger number of handler operations, but you can see that I'm really just doing a couple handler operations per point to come up with where we are. So with that, I'm going to hand it over to Alexander, and he's going to also talk about how this can work through some more examples and then how it translates into MongoDB as well.
All right, thank you. So for the rest of the presentation, what I will talk about is how to actually build the application based on the OpenStreetMaps data. So in MySQL 5.7, there is a thing that's called GeoJSON. GeoJSON is a standard and pretty useful for things like displaying data on Google Maps. So this is what I was going to do. I was going to basically show all the lunch places around our Percona office. This is actually an old office in Durham, North Carolina. And I wanted to have a very quick and easy way to show the point of interest on the map. So what I did is I used the MySQL 5.7 GeoJSON feature to basically extract the data and create a GeoJSON file and show it on the map. So 5.7 again introduced this function called st as GeoJSON, and st as GeoJSON can be used to put it on the map or do any other exchange. So here's how we did that. First of all, there is a OpenStreetMap. This is open source data. You can download that from the openstreetmap.org. Now, it is stored in its own format, but you can easily convert that to the MySQL representation. And MySQL representation will be using the point of interest. So you can use this Augur to Augur open source tool to convert and load it directly to the MySQL. Again, it's using this OSM PBF format. It's a compressed format, but it can be read directly by Augur to Augur. Now, what you will get is things like this. So I'm using this points table. And again, this is the result of our conversion. And the points table have all basically points of interest that are part of this database. There are other tables that I will look at, lines and polygons and stuff like that. But let's start with the points. So the most common query, the most common application usage is give me 10 points around my location. And think about the mobile application or think about any web application that needs to display 10 point of interest or 20 point of interest, whatever it is. Again, what this shows is I want to also filter by what kind of point of interest it is, right? So I want to find all the cafe or restaurants. So another important thing is that we will still need in MySQL 5.7 and also in MySQL 8 so far, we will need to use the bounding box rectangle. This is what we started with, and this is what we will still need to use. So I have created this function, stored function, which is called create envelope here. It will take 3 parameters, latitude, longitude of a point, and the distance. So in the example here, right here, we are creating a bounding box with a 10 miles radius around our point. So again, the whole idea of this bounding box is to restrict the number of points that MySQL is searching. So now here's the example. This is based on 5.7, but I tested it in the 8.0 and it still has the same issue. If you don't have the bounding box, then MySQL will have to scan the whole table. Now, right. So this is a very good question. So why it's doing that, right? So the thing is, we can do an order by, and this is a classical example. We can do an order by distance. But the problem is that MySQL will not be able to use an index with the order by on distance. It can use an index on the bounding box rectangle, and it can use an index on st within. But if you're doing order by, then we'll not be able to use an index. So in this example, on the right side, with create envelope, what we do is we do st within, we create the envelope, the 10-mile radius around our point, and then MySQL will use an index, a special index, or R3 index on the shape to restrict the number of records that will scan. So the difference is huge. Now, finally, MongoDB. So MongoDB has taken a different approach, and from the beginning, it has optimized those queries. It has optimized for pretty much one use case. Give me the 10 points around the current location. It has optimized those queries. The queries are called GeoNear and GeoSearch. It has optimized those queries so we don't need to create a minimum boundary rectangle. How it works in MongoDB, let's see. So here is the comparison between MySQL 5.7 and MongoDB. So in MongoDB, we use the standard MongoDB syntax, but what we use here is this GeoNear construct. So with a near, we will just simply specify the point, coordinates, and specify spherical true. This is the same as using the st distance sphere here. So we'll use the same algorithm to give us the actual distance on sphere. And then we will specify max distance. So this is similar to this restriction will work similar as what we are doing manually here with the create envelope. Here is the comparison, the speed comparison. So I am using the st distance sphere here, and do also this is based on the. I think this is missing from this slide, but there is a envelope here as well. So MySQL is running in 0.21 seconds, and MongoDB 3.2 is in 0.17. So now let's say that we want to have this being exported to MySQL and we want to try MongoDB. How do we do that? It's in MySQL 5.7, it's very easy to export data as a JSON object. And when we export this data into the JSON object, it's very easy to load it to MongoDB. So we just take this file that we have exported, the points.json, and just load it. Right? So far, so good. It's using the parallel load, and we will have all those points in MongoDB. Now, to make MongoDB work fast and take advantage of the indexes, we can, of course, create an index. So this is just a points JSON example based on the OpenStreetMap data. Now, we want to create a 2D sphere index. So MongoDB, like MySQL, will take advantage of the index to be able to satisfy our spatial queries. All right, so we have created an index on points. Now we want to create an index on lines. Lines is another feature, is another table in OpenStreetMaps that basically stores the highways or bikeways and similar stuff. So I have tried to create an index on the lines collection, and what I found is it's refusing to do that. It cannot create an index on the lines collection because for some of the features, it's probably a bug of the OpenStreetMap itself, but for some of the lines, the coordinates are the same for the first point and the end point. So the the distance of this line is 0. So we will have to clean up this data, and as we can see, MongoDB is much more strict in terms of how it builds the indexes and what it stores there compared to MySQL. So we will have to clean it up before we will create the index. Removing the bad data is painful and slow in MongoDB, but finally I was able to clean it up inside the MongoDB without sending data back to the application and to MongoDB again. And then I have created an index successfully on the lines. So finally, here's what we want to do with MongoDB. We want to find all cafes, thank you, near Durham, North Carolina. And this is the example of a command that I can run to get the results back. All right, and this is all. Thank you very much. Any questions?
So in 5.7 you have a bounding box, but let's say you have a mobile app and the user is traveling. So how do you deal with dynamically changing bounding boxes? I mean, is it like you have to, like, I don't know, set new boxes all the time while the user is moving, or?
All right, so the question was how we deal with the boxes when the user location is changing. I mean, in this particular case, the bounding box is dynamic. I'm building it as a part of the query. So I am passing along the current location of the user into my query. So here's, let me show the example again here. It's a good question, actually. So the query here contains the same coordinates as we pass along. So those coordinates are from the user location. So we don't build the bounding box beforehand and pass it. We just create this bounding box as a part of our query. Answer your question? Mm-hmm. Any other questions?
You want to show the...
Okay.
So just to kind of also show you, you know how we started that other process running earlier? We'll see if it's finished yet. So it still hasn't calculated everything, and oh, it's working? It's on? Okay. So yeah, it still hasn't finished yet. We can come back over here and actually see our query, and it's still running. So that's been 864 seconds doing the same query that finished in just a couple seconds earlier. So again, that shows you really the impact of what that spatial key has done and how it has made, you know, all the stuff that Alexander showed as well, you know, actually possible with NODB now. So.
How long did it take you to convert the end data into the 5.7 data? Like the loading and conversion process? Because essentially,
Yes.
because end data changes.
Yes. Mm-hmm. Right. So what the question is how long this conversion takes. I think it takes like maybe 1-2 hours max. So what I did at some point is I set up a cron job that downloads this PBX file for the US and convert it. So every night it downloads this file. You can actually check if it has been updated, obviously, or not. And if it has been updated, I just loaded the whole thing and overwrite.
And so what's the strategy for always keeping your data somewhat in sync, right? So you have a database that has an import, you have your app here, the app goes against the database, and now, a day from now, you want to make a change. So can you import the data, or do you have to have like two different database servers and you swap between them somehow?
We can. So the question is, how do we import only the new data, right? So as long as I'm not sure that OSM in particular provides you with deltas. Right. So because it doesn't provide with a delta, so what I would do in production, I didn't do that in production, but what I would do in production is I just create new tables. and just swap them, because you don't want, I mean, as long as you start overwriting, right, it's a different state, so we don't want that. So just create a new tables and rename that. Rename is atomic, so you can rename multiple tables at once, and then just new queries coming up will start seeing this, new tables. All right, any other questions? All right, thank you very much.